Think of your network as a live concert, cables, connections, chaos, but the show must go on. Today's networks need more visibility. They need precision tuning, real-time response, and zero noise. And that's where agentic, I always have an issue saying this word for some reason, AI takes the stage, orchestrating investigations, tuning performance, and stopping threats before they hit the main set. So today we're going to talk about how AI agents are redefining real-time network tuning, threat hunting, and operational precision. So let's drop the beat, let AI lead, and Adam Horwith is your MC for today. Take it away, Adam.
Awesome. Thank you, Peter. So for our Tech Talk series over the last few months, we've been kind of walking through a lot of the features and functions of our AI ML engine, kind of how those work and detecting, more advanced characteristics of problems on a network, whether it's performance or security. Today, I wanted to take a slightly more forward-looking approach at where we're going and just kind of let everybody know how we're adapting and thinking about the landscape as everything changes so quickly with new AI technologies that are out there. I think at this point, everyone has probably at least tried like a ChatGPT or Gemini or Claude type solution in their workflow, getting an idea of how well it can perform, when it's right, when it's wrong, when you need to be skeptical of it. And I think if you've been following along for quite some time, those probably came out as consumer products in mid 2023, and they were okay. And as you've noticed over the years, they've improved fairly considerably, and the roadmap for all of them shows in the next 2 or 3 years that they'll be production ready in every sense of the word. So that's what we're going to cover today, is kind of the state of where our platform lives now, and really our thinking around the future and how we're getting ready to live in this agentic AI world, where your live network data and the analytic results from your network data observability stack are going to be more important than ever, because they're going to actually feed into a feedback loop with things that can make mutable changes on the network. So just quickly to begin, I just want to talk about the AI engine component of the Plixer platform. So the Plixer platform is Scrutinizer that everyone's used to, the actual NetFlow and IPFix collection analytics stack. It's where all the deterministic algorithms live, very fixed set things like, is this a scan? Is this a brute force attack? Things that you can just tell generically in any case. Our AI engine is a separate compute portion for very heavy analytics. And it brings quite a few interesting features that are relevant to what we're talking about today. So right off the top, it enables Kafka streaming right away and becomes a Kafka broker in your environment with a standardized set of all of the NetFlow that's an IPFix that's coming into your platform. So if you have multiple different vendors and devices that are sending all sorts of different record types and information elements in, the Plixer platform can standardize those in a way that you can consume them and process them in a uniform way, and it makes them available in a Kafka broker, which means any Kafka consumer that you throw in an application can get a live feed of the data that's on your network, just the same as our AI tools do that live on the AI engine. So I'm not going to go too in depth on them today because they're a little bit outside of the scope and they're things we've covered in previous tech talks, but it is where all the non-deterministic analytics live. So all the things that need to learn about your environment, all the inference is real time, again, because we have a Kafka broker that offers real-time observations from the network. And then ultimately it hosts the forecasting engine, our malware traffic classification, our encrypted traffic analysis. There's an intelligent DNS proxy, our behavioral anomaly detection, which was the focus of our previous tech talk. Those can be found on YouTube if you're interested. And our graph-based anomaly detection, which was I guess 2 tech talks ago, again, available on YouTube if you're interested in going into kind of the low level of how those things work. But ultimately, all those things are enabled by the fact that there's a Kafka stream that has now taken all of these bespoke data sources and standardized their output and made them available for consumption in one place. So a little bit outside of the scope of this, but if you are ever interested in, now that kind of vibe coding is a thing and you can go out and ask Gemini or whoever for maybe a quick Python script to do something with your network data, do keep in mind that if you're running our AI engine on the Plixer One enterprise platform, you already have a real-time feed of data on your network that you can subscribe to with kind of whatever you get out of your Gemini coding experience, and you can immediately start experimenting and applying new things that you think of to your network data right away. So it's kind of a subtle feature of this component, but a very important one as we talk about, what can be done with network data. And, as data science and network engineering start to bleed into each other, how can I actually get access to my real-time observations so I can explore and try various analytics with them that are maybe outside of what's in the offering that we ship. So I want to start today with really the main focus. So our upcoming release is bringing a chat agent into the UI of the product that's going to have two major functions in its initial release. And we're really keeping the scope pretty limited to make sure that, it's a valuable feature and everything that it does is pretty well contained and makes sense. In the initial offering, we're doing is we're bringing context from your environment together, the IP groups, the defined applications, the exporter security groups, everything that our platform knows about as far as the context of your environment. We're bringing that along with the real-time network data that we see, the real-time output of the analytics that are running on the platform, and ultimately joining those together with natural language. So for the longest time, and we'll cover it kind of a few times over as we go through, but for the longest time, really the usage you could get out of most products was somewhat limited to how good of a user of that product you were. Are you a power user? Have you gone through training for it? Has an update happened that maybe changed the workflow for doing various things? What we're going to see as AI kind of creeps into all other products, and again, a lot of us are used to like a chat GPT style inference. Maybe people who have a little bit more advanced workflows have been hitting an OpenAI API on the back end and maybe integrating LLM interactions into their own projects. But ultimately, really that pivot of using just natural language to get to results rather than kind of needing to know how to orchestrate and operate a platform between you and the results is going to be the major innovation of this initial step here. So we'll walk through kind of what that looks like, and then we'll start to explore the future after that. So in an existing workflow, around network observability, especially with our platform, it might start with some sort of user submitted ticket or alert that suggests there's either performance degradation on the network or some sort of security issue that's happened. So when it comes to investigating that in order to kind of get context around what's going on and then ultimately lead yourself to kind of the remediation steps, it really begins with figuring out what exporters on my network are relevant to this situation. So immediately the user has to integrate some context and knowledge they have about the environment in order to even select what input data is going to be important to their investigation. Once that's been selected, you have to go through and pick a report type. What kind of data quality do we want to look at? How do we want things grouped? How do we want things aggregated? What type of information is going to help lead us to a resolution to our problem, or at least describe a scenario in a way where we now have some sort of actionable insight that we can apply backwards in. After that, we have to apply filters to the result of those report types. Maybe there's only specific hosts we're interested, or ports and protocols, or applications and services that are the kind of subject of the study that we're running. And describing those things can be somewhat verbose, and we have lots of powerful filtration tools, but again, it does require the user to kind of understand, what and where to apply those filters in order to get the best results out of their report. And then finally, the report comes back. We get the results we were looking for. We kind of understand what was going on at that point in time on the network, and we can pivot from that into kind of our remediation steps now that we have some context around, this user or application log said there's a problem or degradation or security, whatever it is. We go through the steps of isolating that traffic. We identify it, make it available in a report, and then we ultimately use that data to go back and remediate the problem. So lots of steps, lots of kind of time dealt. We talked MTTR in a previous talk. A long time between kind of identification of the problem and approaching the beginning of the mitigation steps and what we're going to do about it. So in this initial offering, and this is a lot of what we showed off at Cisco Live in product, is going to be flattening that whole process down to the kind of the chat style interfaces that we're getting used to across all these products, and then having that drive directly through to the report with all the filters applied and the input data selected and the report types kind of becoming transparent to the user themselves, and instead going directly from intent that's described in language right through data that describes the situation that we were hoping to get context into. So in this case, some of the abstractions become a little bit more obvious when you start to see some example questions. In this case, I asked, can you find evidence of a slow loris attack? A slow loris attack being when a few sets of hosts will open large amounts of connections against something that's serving maybe HTTP traffic, a web server, whatever. And then it ultimately just delivers the bytes of that connection at the slowest possible rate, where the server itself won't close the connection, but the client kind of just trickles information in, implying that it's an up and active connection that maybe just has, a lot of latency between the client and the host itself. So it's a common attack that's an availability style attack. I always like to focus on availability attacks because it kind of hits the middle of the Venn diagram between the two houses. I always say an availability attack is also a performance attack because it's effectively going after the operation of an application or platform. So it will be felt from a performance side, but it very well may be a security issue where someone is kind of attacking that thing. But at the end of the day, it rather quickly becomes the same symptoms and causes a lot of the same problems that can be observed by users. So again, can you show evidence of a slow loris attack on a specific subnet? It'll go through, there's two major operational modes in this initial offering, which is product navigation, finding the options and settings and views that are going to be important to you without really needing to master the product, as well as getting right into report data. So in this case, I selected to go right to report data. And you can see to detect potential slow loris attacks on that network, it ran an inbound focused traffic report looking at the connection counts and protocols that would signify that attack. And then if we look at the filter on the right-hand side that was built by the LLM on the back end, we can see that it included only traffic to the subnet we were talking about. It included information from all domains, because we're just looking broadly, and then ultimately filtered down to just HTTP and HTTPS traffic across TCP and UDP protocols. So what this ultimately does, again, is it takes a process where there's a lot of information that a NOC operator or SOC operator would need to know to explore an event like this. And we can actually leverage some of the inner workings of the LLM to both describe the problem we're looking for and then ultimately translate it into the data types and structures that the platform expects in order to return a report that's going to have some significant result for you, and ultimately kind of tell the story that you need in order to begin the remediation and mitigation steps of the response. So how does an LLM help for these things? So LLMs, again, they're basically word completion tools that have been trained on the corpus of all human text at this point. So every book that was written, every Reddit post that was ever made, it's combed the internet a few times over at this point. Now I think they're primarily into the world of generating synthetic data because they've consumed all of the data that was out there to further kind of increase the base knowledge of these models. So some of it comes down to the selection of appropriate models. We use a lot of like coding and computer science focused models in our default offering on the back end. And what you really end up getting for that is a general knowledge of the space that includes things like what ports and protocols would be relevant in a slow loris attack. So now a user or an entry-level SOC operator, can be generally aware of an attack type without knowing the lower level implementation details and still query the platform for evidence or network observability records that show these type of things are occurring. So a combination of that general LLM knowledge, the prompt the user provides, so the actual question we ask it, and then ultimately some local context, like I mentioned before, the IP groups, the things that are defined in your network that the platform knows about, unifying those three components, and then we've effectively taught one of these LLMs in order to how the query and the back end works for a reporting interface, creates a bridge that happens seamlessly between your input and like kind of initial investigation steps and ultimately getting you right to the data that's the output. Peter, if you don't mind muting, there's some like cross talk coming through.
Oh yeah, no, sorry to interrupt. There was a question that popped in the QA. So do you use fine-tuned or pre-trained LLM / proprietary, and is it on-prem or in the cloud? And yeah, I'll go back.
Oh, for sure. Yeah, great question. Kind of the paradigm that we've gone after is the assumption that in a lot of environments, especially highly secure environments, external LLM access is not going to be available. So what that ultimately means is quite a lot of environments are going to host their own LLM services. It will be a fairly considerable infrastructure investment, just because I think we all know kind of the general GPU requirements and VRAM requirements around hosting these smarter and larger models. But we did think it was very important early on. So we do have an Amazon Bedrock backed default instance that can be used. We chose Amazon Bedrock because it's HIPAA compliant. It keeps the data safe. It doesn't log anything. It's really a place where if you need LLM inference in a secure way where data can't be leaked, et cetera, that's a service that Amazon offers. So that's by default what we tie into. Uses a lot of Anthropic backend because those Claude models are very good with coding and computer science in general. However, any LLM that's OpenAI API compatible, and that doesn't just mean OpenAI models like ChatGPT o3 or GPT 4.1 or anything like that. OpenAI API is just a standardized API layer for accessing LLMs that are hosted on Ollama or Llama CPP or however you're hosting your local models. So in the default initial offering, you'll have an option between both. If your policy does not allow for you to use our backend, which again is compliant and secure, then there is an option for you to run them on your own. Because of that, to answer the other part of your question, we do rely on general purpose LLMs as opposed to fine-tuned ones. So there may be a point in the future where we have various levels of offerings where we fine-tune some around specific use cases, but in favor of portability, we've gone with some fairly verbose system prompting that explains kind of the functions and backends and how to use some of the intermediate APIs that it has available to in tool calls, which we'll talk about later, in order to get from your intent into the report data on our platform. So hopefully that answers your question, but we do support both our cloud backend LLM as well as any LLM that is OpenAI API compatible that might be in your environment. So there's no requirement to link your data into any other system if you have the infrastructure to host that yourself. And again, kind of implicitly, that's why there isn't really a lot of fine tuning going on, is because then it would be a matter of transferring kind of these giant models around to anyone that needs to be private in order to get good use out of it, where it seems like a safer future roadmap is to make sure that you're portable among the leading LLM offerings. Additionally, the benefit of that is as these get better, we can just keep upgrading the backend model. And really, this general LLM knowledge component is what benefits the most from that. These things are only going to be as current as when they were trained. So anything regarding model updates is always going to be important for having newer information, newer, understanding around common attack patterns and things like that. So hopefully that answers the question. So I do want to talk a little bit about the context embedding part of this. So again, on the platform, we know quite a few things about the things that are using the network, the entities, whether that's exporters and their interfaces, the actual infrastructure of the network, or the hosts that live on the network and how they're using it. So when you ask a question, one of the first passes that goes across the question is in kind of identifying the intent of what you asked the Plixer AI chat, as well as finding all of the nouns that are in there. So if we were to think about like a question that's like, what are my top DNS servers over a period of time? DNS servers has kind of a specific meaning. It could just be in general, what are all of the devices that have, UDP 53 or HTTPS 53 going to them? But on the platform, that can be more explicitly defined. And a lot of our security algorithms have places for defining that in order to identify rogue DNS servers, et cetera. Ultimately, what that enables us to do is we can take those definitions and embed them in a vector store. So vector databases and vector stores are going to be a popular term that's come up a lot in the last few years, whether that's Chroma or there's a few Rust-based ones. I think Snowflake has some offerings along this line. But ultimately, vector stores take concepts and embed them in a vector space. There's a very old now, but popular kind of LLM example where words in the English language have some semantic difference when they're encoded into vector space. So the very popular example was always like king minus the concept of man would end up with a vector that points to queen. So it's just kind of an interesting way that you can actually take the semantic meaning in language, encode it into a vector space, and then ultimately do operations on those tokens or composite tokens in the case of longer words, and then do operations on them in that space where you can actually find how the differential between the semantic meaning in two terms operates. So where that becomes a benefit for the workflows that we're talking about here is we can take something like DNS servers, run a cosine similarity check against that term into a vector database where we've already pre-embed all of the kind of nouns that we know about your network, and ultimately identify other terms or definitions that are semantically similar to what you asked in your question. So in this case, we ask, what are my top DNS servers? That noun is identified. It is embed itself into the vector store, and then a cosine similarity is searched around where that embedding landed. In this case, if you view that kind of dotted circle as the acceptable bounds of similarity around a point, we can see it finds 3 other points. And just as an example, those could be your actual DNS server IP group, maybe your DNS proxy IP group, and maybe any external DNS servers that you've defined that are approved for use. So again, quickly, we can take the question that was asked, find the things that are in there that you're talking about, and then map those things back into the actual kind of token embedding space that LLMs operate in. So that way we can unify the context of the network, the user's question, and then ultimately get through to some data that's relevant to both of those things. A secondary function that I mentioned earlier of all of this is product navigation. So in the past, really a lot of tools were as strong as kind of your strongest power user was in the environment, someone who knew where all the options were, where the configuration settings lived, how to actually take advantage of the full kind of feature set of a product. So alternatively, while you can ask questions that are about reports and kind of skip the whole report building stage and get directly into data that you're interested in, additionally, you can navigate the product this way and say, take me to the flow analytics configuration page, a process that previously would involve navigating into the admin settings, going through figuring out kind of what subcategory is what I'm looking for in, maybe alarm monitor, flow analytic algorithms. And now we've landed on that final page with really not a ton of context. In this newer model, what we're focused on is allowing someone to basically ask questions around the features and functionality of the product, and then just deliver them directly to that view, along with a link to the documentation so they're aware of how to operate it. So again, it's things that seem fairly small and insignificant at an initial pass, but then turn out to actually be quite powerful once you start using it in production. In our kind of pre-alpha development views, I rarely find myself navigating the product like I did traditionally now, even though I know where a lot of these options were, specifically because it's just faster to say, open this view, and it takes you directly to that view. And again, if there was any reason to go into the documentation, figure out, for this flow analytic algorithm, what type of devices should be considered, et cetera. All of the tables that kind of have helpers and assistants are immediately available through that documentation. And as we develop this solution further forward, we'll embed a lot of those things from the documentation into the chat as well, and pretty quickly eliminate the need to ever leave the chat window, and instead just converse back and forth from that view about, what should my next steps be? What are the best practices here for my use case? What would the best combination of these things be, et cetera? So those are really the two initial primary functions. And what I want to start talking about is why that's important. So we have access to data and access to the features and functionality of the product. And ultimately, what that is going to enable as we move forward is an agentic approach to AI. So that was kind of the headline topic of this talk. And it's really what the next few years are going to look like. As anybody that's really following along closely, kind of these wars between Gemini 2.5 and now Grok 4 this week, and I'm sure OpenAI has some GPT-5 or O4 model that's going to drop any day now. We see these incremental jumps in the actual kind of compute and intelligence side of the LLMs. Again, these really just giant word completion tools, but they get better and more efficient at that word completion process as we move along. We're going to start to see those converge on kind of their ideal intellect set. And that's already being observed quite a bit in the research, where different training techniques for LLMs and different modeling techniques and embedding practices, even for, like we're talking about, context in a vector store, even though they use different mathematical models under the hood, they're actually starting to converge around the same definitions and understanding of concepts. So it does mean that for the most part, unless there's some fairly substantial change in how the back end of these transformers work, pretty quickly, really all that's going to be differentiated between them is kind of the label and the company that you're using on top of it. So really, once that level is solved, and again, we're nearing it rapidly, people expect by the end of this year or mid next year, that layer is going to effectively be as intelligent as it needs to be to solve most problems. The world we're moving into is an agentic pattern. So in an agentic pattern, we take a task prompt in. So here's a goal and maybe some constraints that I'd like you to operate along. And rather than working in just a chat style window where it's very asynchronous, here's my prompt, here's your answer, here's my response to your prompt, here's your updated answer. We're going to start to look at a model where we give a high level prompt and then the LLM just kind of spins, looking at exogenous data series, looking at tool calls that are available to it, taking actions, and then seeing how those actions, made a mutable change on the environment, and then reevaluating. So really the same concept as a human kind of in the loop with a open and live chat experience, but instead pivoting around the idea that, we can close the loop here, give it feedback data and an objective, and let it just run and continue to optimize against that objective. So really the main components of that, again, are going to be the task prompt. What is the overall objective of this agent? Tool calling, which we'll talk about a little bit more in depth in a moment, but what is available to me as an LLM agent to go out and collect information? And then ultimately, kind of a subcomponent of that tool calling structure is what actions can I take and what effect will they have on the network? And then ultimately, how can I look at observations from the space that I just made a mutable change to in order to see if my actions actually did what I thought they would do, or if it didn't exactly address the problem as the agent thought it would, what did happen and how can we take that feedback from the observational loop and then improve our action to really start to clamp down on kind of whatever the objective is. So looking a little bit deeper into tool calling, these will start to feel familiar. Again, if you've used a lot of the consumer level products and seen what's available in those offerings, but it's kind of fun and exciting to think about how this might grow and change in the future. So at the most basic end, live web search is available in most of the premium offerings now. That is a tool call. So you go out to ChatGPT 03, and you make a query that says, can you tell me everything about webhooks and how applications talk and inform each other over webhooks? If the LLM doesn't have a base understanding of it, or maybe it even does and still makes the tool call anyway, a lot of them now have tool calls available where the LLM in natural language knows how to submit a request to an API that will go out and effectively Google something, aggregate the results, and then return the results in a natural language way that initial agentic context can process those results and actually learn something from it or navigate further into those sites that were returned and gain a kind of contemporary background knowledge of the problem. Additionally, you'll see code interpreters. A lot of times there's certain things, if you give like a table of data that's maybe in an image to a ChatGPT style service, it can't necessarily read the image directly. So it will actually spin up a Python code interpreter, load pill, load the image in, start to extract text from it. And then once it's back in text, we're back working in language, and that's where the LLM lives, and it can actually make some use out of it. So things like code interpreters tying in are another example of tool calls. Our reasoning models that we see a lot, where maybe, again, O3 is one, where you ask a question, and then you actually start to see kind of the chain of thought of what is the model doing, where it effectively just spins up lots of LLM agents that look at your initial prompt and do some work around identifying the intent of your initial prompt. What are good follow-up questions for that prompt? What's a good order of operations for identifying things that need to be done? It's really just lots of sub chats that are opened. And then ultimately they'll come to some consensus, feed their consensus back into your main chat thread. And now it has a little bit more context again to operate against your initial question on. So another tool call. Where things start to get interesting is when you talk about live data access and maybe blocking actions. So in the case of live data access, somebody asked earlier about fine-tuning models. There are methods for giving LLMs lots of new examples of data, fine-tuning them around those new examples of data, and then freezing the model there with an understanding of kind of how those concepts work together. But there's really no way to take something that's at extremely high volume, like flow data, where you're probably talking hundreds of thousands of events per second, billions of events per day, hundreds of billions of events per year, and embed all of those in a way that makes some semantic sense in language into a model without basically making its context completely incoherent because it's overloaded with just these A to B style network observability records. So it became clear to us at a certain point that our platform to live in this new world of agentic AI really needs to be open and available for LLMs that aren't even the Plixer AI itself, maybe some enterprise level AI that's doing some other investigation or solving some problem that will need access into, well, what is the network doing right now? If I'm studying some specific subject, what are the network events that are related to that subject that I can then use in conjunction with other business data in that study? So that's really when we talk agentic AI in our platform is we have offerings now in the UI just to make life easier for people with some AI leverage. But ultimately, the goal of those functions was building the backends. So that way, when in the near future, other LLMs need information about the network and the current state of the analytic output or what state a host is in, there's a place for it to come ask a question in natural language and make that tool call and get some sort of digestible result back that describes that active state on the network, or again, kind of the active situation as far as analytic output goes. And then finally, tool calling in all those examples was very query based and getting information to build the context out. But ultimately, any type of action that an agent can take is going to be along the lines of a tool call where it can go out and actually change an ACL, in our case, in the network world, or if you're in the accounting space, go out and actually block a user's ability to put something on a general ledger, things like that. So that's also going to be a tool calling space. So when we really talk about this agentic AI pattern, it is just important to consider that now we have effectively a chat that's talking to itself that has the ability to spawn sub-threads and collect more context and more data and effectively just change that initial task prompt to a prompt that has lots of background information and lots of context around exactly what's going on now. Take an action step, reevaluate, make tool calls to get observational data back into that context, and then continue that process where it can say, we've done these things, we made this action, this is the measurable change in the observability data that we saw. Let's make another action, another change in the observability data, and ultimately it can work towards converging towards the ultimate solution that was in the initial task prompt. So for not just our platform and your network data, but for any real tool you have in your environment that's ultimately one day going to participate in these larger enterprise LLM level kind of problem solving schemas, it's going to be very important that your tools have endpoints available that can be used as tool calls. So again, we've exposed those endpoints for users in the UI, again, just for kind of ease of use and quality of life. But ultimately, that is really the real intent, is that we see over the next few years that more and more platforms like ours are going to be relevant to the workflows of agentic AI patterns almost as often, if not more often, than they are to actual users and kind of the workflows that we're used to today with logging in and querying and taking that data, making a decision ourselves, going and making the action. Really the same pattern, right? Taking the action, coming back, looking at the data and making sure that our action had the effect we thought it would. Again, boiling all that down into something that's just happening automatically on the back end, and then we really just operate as kind of supervisors around those processes. As far as, just as an aside, as far as kind of the argument around like, is everyone going to be unemployed because of this? I suspect we'll just get a lot more done. Over time, tools have come out that have helped us leverage our workloads, and we just get more done because of them. That's more than likely what we're looking at as we move forward, is just kind of same people serving the same roles, but with this leverage of AI tools that just allow you to get to all the things that otherwise it feels like there's never enough time to do. So I just want to kind of capstone everything with a more tangible example of what this really looks like. And I think about this one a lot. I came from an ERP background, Microsoft Dynamics AX, where you have your accounting data and your network data and your POS operations and your HR data all live kind of in one database together. And I often think about once enterprise LLMs are available and they have access to use tool calls against a platform like your ERP, as well as a platform like the Plixer platform and all of your live network observations, you could think of a task that says, go out and monitor all of the accounts payable users and block any suspicious actions they take. So you have some subset of users in your environment that have actual access to, finances and financial actions. So, these things are obviously already audited fairly strictly currently, but they are audited at human speed. What does a world look like where something that's faster than people can also monitor these things and take actions to stop problems while they're in mid-flight rather than kind of waiting till it's over and investigating and then taking remedial action? So for this example, you could think of tool calls as going out and looking at application logs, looking at your general ledger software, figuring out what type of events have been put in, taken out, the network logs that are around the actual workstations that those personnel are using, ERP lookups, are there inventory changes, kind of figuring out if the application logs, the network logs, then the actual business logic all make sense. And then ultimately our list of blocking actions that can be taken, whether that's on the ERP platform or the accounting platform or directly against the network itself. Block the network traffic or block the user's access to make those changes in the accounting software. There's lots of, kind of multimodal actions that can be taken. And then ultimately, kind of our loop on the right-hand side, it looks like it kind of presents like a separate thing, but it's really a stack of those tool calls as the agent can go out, it says it's reviewing application logs, it's reviewing the ERP logs, it signals, a transaction on the ledger does appear to be strange because from an ERP perspective, it doesn't make sense. At the same time, it can then go, okay, well, it was done from this workstation by this user. Let's go out to the Plixer platform's agent and query all of the live network data that's relevant to this situation. Pull that all back. Again, really just reinforce the context of that initial task question with now a bunch of background information, and then go out and make an action. Maybe it is block that, first, the fastest thing is reach out, block that agent or that host from being able to even access the ERP platform or the accounting platform at all. And then secondary, send requests into those platforms themselves to restrict that user's ability to do things. And then finally, again, we have an observational loop. It can keep monitoring those things. You block that user. It looks like that was actually ineffective. You still see this kind of weird behavior happening. And then it can go back through and unblock those things and work that out. So again, things that people are doing now, but just closing that time delta between reviewing information and taking action, and reviewing information and taking action, the kind of those state space updates that happen in between. A lot of that's going to collapse very quickly as these tools can talk to each other. So again, that's really, as just kind of in wrapping, that's really the high level big picture for all of this is how do we make the platform be able to operate at AI speeds and answer questions that AI agents are going to need in order to actually go out and operate tasks on their own, whether that's with human supervision or without. We'll see kind of how that works as time goes on. And then ultimately making some of those tools available to users that are in product now so they can get the benefit of those while we're really waiting for the world to come around to this new paradigm. So with that, that's kind of the information I had to present today. I really appreciate everyone joining. I'm not sure if you have any follow-ups, Peter, or maybe there's some questions.
So yeah, so one of the things, and you touched on it quite a bit, the whole, when an AI can just mitigate automatically, I think that's sort of where folks would like this to head. And some estimates are like late 2025, give or take. My personal thing is I still think there should be at least some human interaction at this point, as trust needs to build within these systems doing their side pieces. I'm curious what your time frame is, because all along you're like near future, soon to be.
Yeah.
The estimates like are 2025, but the way these new engines are coming out, it very well could be sooner than that.
Yeah, 2027 and 28, just because it's the technology is certainly getting very close, but if you think realistically about implementation timelines,
Yeah.
a lot of the people who are studying the deployment of this are showing 27 and 28 as being kind of generally accepted use of a lot of these agentic kind of closed loop situations. But to your point, I think we're quite a ways away from removing the responsibility from people. I don't even
Yeah.
think there's really like a legal understanding yet of how to, fully automate a lot of decision making and then figure out like where the actual responsibility lies around the decisions that are made. So I suspect there'll be people supervising these things for quite a while, but really it's from the optimistic side. I have lots of friends that are graphic designers and stuff that are really being impacted by a lot of this now, as
Yeah.
generative AI is tremendous at creating images and creating marketing tangibles like that. But it's your career was always going to be a fixed amount of time, and you kind of just have to ask yourself the question of like, how much do I want to get accomplished during that fixed amount of time? And we've never had a situation like this where there's so much technical leverage available where we're going to be able to get 100x what we would have been able to do otherwise with all of these tools. I mean, it's really not much different than people moving from like an abacus to a calculator, where it's like, well, now I don't really know how the math works, and it's like, you'll be fine. I think we
Yeah.
all drive, for the most part, I don't want to speak for everybody. I think we all drive cars that we don't really know how they work. But the leverage of using a vehicle gets you around and you accomplish a lot more with your time because of that mechanical advantage that it gives you. So I think for the near future, as far as most of us that are already in the space will be impacted, I think we'll end up supervising lots of these sets. You'll probably see entry level roles first kind of replaced with these things, but again with a higher level person that does have experience and does understand like really what needs to be happening in the environment, authorizing those choices and working around them. I know with on the engineering side, some of our development side tools, have multiple operational modes. Some of these coding agents can already work mutably against your environment, but a lot of them have kind of a review mode and an action mode. So you can run it in review mode, see what it would actually do with the tool calls it can make and the information it gathers against your overall task prompt. And then ultimately, once you're satisfied with how it's described its solution, you can pivot it into action mode and it'll go out and take those actions. So that's probably a paradigm you'll see for quite a while. But again, from our perspective, where we're very much a data company, our focus is around how do we just get data into those environments? How do we make sure when you want to build this agentic platform, your live network data observations and analytic output can be considered in those workflows without a big ball of API spaghetti making it happen where it's different for every user. So
Yeah.
that's really the main focus, I think, for our data platform, and probably any other data platforms that you're working with are going to be just how do we remain kind of the authority for information in that domain in these agentic patterns.
Yeah, I think you agree that in the future it's real musicians writing real music and songs, because I know those AIs are coming hard. Thanks for watching, everyone. We also want to make you aware we have a upcoming webinar July 13th, July 31st, and it's observability beyond the core, being able to do data collection from your full estate, extending the visibility and defense beyond your headquarters into every remote site, every IoT device, every cloud workload. Hopefully you can join us for that. Great session today, Adam. Thanks for presenting this morning, and thanks to all of you for joining. We hope you enjoyed it. You can follow us at Plixer on Twitter, subscribe to our at Plixer One on the YouTubes, and of course, you can always visit us at Plixer.com. For my pal Adam, great job. Nice to see you. Thanks
Thank
all
you,
of you
everyone.
for joining, and we're with Plixer. Have a great day.